Assalamualaikum and hello everyone. Today, I will be presenting a critique of Bolstead et al.'s 2021 study, Emergent Premises in Student Experiences of a First-Year Electrical Engineering course. The study explores how project-based learning, which is PBL, and pedagogical scaffolding influence student transition into engineering education. So, through thematic analysis of student interviews, three key themes emerge, which is socialization, curriculum integration, and peer learning. While the study's qualitative approach provides deep insight, its limitations include potential biases and limited generalizability. Nonetheless, it contributes valuable knowledge to engineering education, emphasizing active learning. Future research should be expanded on diverse student population and long-term impacts.
The study explores the hidden beliefs and assumptions that shape students' experience in their first years of engineering. While past research has focused on student retention, curriculum, and teaching methods, much of it overlooks the cognitive and emotional challenges students face. The study shifts the focus to these underlying factors, revealing how they influence engagement, motivation, and learning. Using a qualitative approach, the research analyzed students' narrative to uncover patterns in their experience. Understanding these emerging assumptions can help educators, curriculum designers, and policymakers create a more supportive and effective learning environment. As term education undergoes reform, addressing the nuanced struggles of first-year students is crucial. This study contributes to the conversation of educational innovation by offering student-centered insights into course design, teaching strategies, and learning communities.
This research applied a combination of quantitative survey data and qualitative case study analysis to get a comprehensive understanding of student experience. However, multiple methodologies were applied. The qualitative component relied on data from Study Barometric National Survey, while self-reported responses provided useful insight, response bias, and unconsidered structural variation result. Difference in demographic characteristics and institutional backing between LCs and other Norwegian programs also pose challenges. The qualitative component involves semi-structured interview with 6 students, offering deep insight but limiting the broader applicability of the finding due to the small sample size. The selection process, which considered student electronic knowledge and team diversity, did not fully represent the perspective of all students. Thematic analysis was used to interpret the data, but as a subjective method, it carries potential bias. The research approach effectively captured student experiences, but limitations should be acknowledged, including dependent data, a small qualitative sample, and potential biases in data interpretation. At NTNU, where the experience of first-year LC students are explored through a mix of quantitative and qualitative research, Study Barometric, a national survey by Northwood, was used to assess study quality, learning environment, and engagement levels compared to other electrical students in the Norway. 6 students were selected for a case study representing diverse project groups and varying levels of prior electronic knowledge assessed through a questionnaire. At the end of the semester, semi-structured interviews were conducted, allowing students to share their learning experience and perspective on the educational environment. There were thematic analyses identified, which is 3 key themes: socialization, curriculum integration, and teamwork, highlighting interaction, coursework application, and collaboration. An independent researcher led the interview to prevent bias, ensuring that students could express themselves freely. This research provides valuable insights also into student engagement, learning experiences, and professional development in the ASIS program.
Hello everyone. So I will be sharing the result and conclusion part from the article. This study of LC's program scores slightly higher in the academic environment satisfaction and significant higher in the interaction between student and faculty compared to the other electrical engineering program. The student also felt more comfortable and motivated for them to study during this program was conducted, and they appreciate the program and industry connection. Other than that, Three key themes emerge from the interview of the student, which is socialization, curriculum integration, and peer learning. Through socialization, the student build strong connection with their peer as the program focus more on teamwork rather than mastering electronic. Curriculum integration help them link the different courses in the university and making the learning more meaningful. Meanwhile, peer learning provide the opportunity for the student to learn a new thing and a new knowledge from the other teammates. Continue for the result and conclusion part of the critique. The program stand out for its positive learning environment, strong student engagement, and industry collaboration. However, while it provides useful insight, the study relies on a small qualitative sample size, which is only 6 students, and making it difficult to generalize the finding and the result. The conclusion reinforces the benefit of project-based learning (PBL) and curriculum integration that prove how small course modification can significantly improve the student engagement and motivation. However, the study only focus on of the student of first semester in the electrical engineering program and does not consider a long-term impact on student academic journey.
Hi everyone, my name is Zibin, and today I'm going to present a critique of the article Emergent Premise in Student Experience of a First Year at Electrical Engineering course by Bolster Exeter. This article looks at how project-based learning affect first-year engineering students. I'll first explain the article's limitations and suggestions, then share my critique. The article points out that students come in with different backgrounds. Some know programming and security, while others don't. This leads to experienced students doing most of the technical work, leaving others with simpler tasks. The short 8-week timeline also makes students focus on finishing the project instead of learning new skills. To fix this, the article suggests that giving students more deserved tasks like hardware design and data analysis so everyone can contribute. It also recommends extra programming help and rotating roles so each student gets a chance to work on different parts of the project. Now, moving on to my critique. The article mentions that students need maths and physics knowledge but not programming experience. This creates an imbalance where experienced students do the important tasks while extra support is useful. I think having a basic programming workshop before the course would give everyone a fair start. The article also said students hope to improve teamwork skill, but the short timeline pushed them to focus on completing the project. I agree with the suggestion of using a phased timeline. First, understand the concept, then working on technical parts, and finally putting it all together. This way, students can learn while building the project. Finally, the article explained the program is the biggest skill gap between students, so this makes it hard for students without programming knowledge to contribute fully. Role rotating is useful, but I would also suggest splitting the project into different parts like hardware, data analysis, and programming. This way, students can choose tasks that match their strengths while still learning new skills. To sum up, the article gives useful ideas on project-based learning. It highlights key issues like skill gap, short timelines, and programming relevance. By adding pre-course workshop, phased timeline, and diverse project tasks, students could have a more balanced and effective learning.
So lastly, in summary, Bolstead et 2021 study examines how project PBL and scaffolding aid first-year engineering student transition. Through student interviews, 3 key themes emerge: socialization, curriculum integration, and peer learning. While the study offers valuable insight, its small sample size and specific context limit generalizability. Still, it underscored the role of PBL in fostering engagement and easing the transition. Further research across institutions is needed to strengthen its findings. That's all from us. Thank you.